Bismillahirrahmanirrahim. Our today's lecture is Introduction to Derivatives using formulas. So our first formula is derivative of a constant function is always 0. So let y is equal to f of c be any constant function, where c is the value of function which is always constant. So we take dy by dx on both sides in order to differentiate with respect to x. Now since it is a constant function, so we simply put 0. This is the formula. Whenever we have a constant function, its answer will always be 0. And how this is 0 we will prove shortly. Now let's prove this, how the derivative of a constant function is always 0. Now here we suppose let y is equal to f of c, which is a constant function, and by the definition of the function y is equal to f of x, we can replace y of equation A by f of x, this. So f of x is equal to f of x. Now we will use the formula to prove delta y by delta x is equal to limit delta x approaches to 0 f of x plus delta x minus f of x whole divided by delta x. Here we have used the limiting method, which is delta x approaches to 0. Now what we need now is f of x plus delta x and f of x. So f of x is already given in equation, we can say B. So adding delta x on both sides of equation B, we can get the required f of x plus delta x. This is given. So we will add where there is x, delta x. So we have added delta x, but on the other side, which is f of c, is a constant function and has no variable x, so we cannot add delta x, so f of c will remain as it is, and we can mark this equation as c. Now we'll put both these equations in equation number 1. This is delta y by delta x is equal to limit delta x approaches to 0, so f of c minus f of c whole divided by delta x. This f of c and this f of c is cancelled, and which will be naturally 0. delta x approaches to 0, 0 over delta x. Now anything which is 0 over is 0, limit delta x approaches to 0 and 0. Now applying limit, on both sides, limit delta x approaches to 0, delta y by delta x is equal to, now since 0 is a constant and we know that limit of a constant function remains same, so it will be 0. Hence we get derivative f dash of x is equal to 0. This shows that the derivative of a constant function is always 0. So we have proved. Now one thing should be noted here, that on applying the limit on both sides, limit delta x approaches to 0, delta y by delta x has become equal to 0. Now this side, which is limit delta x approaches to 0, delta y by delta x, is always equal to dy by dx. So we have written it as f dash of x. That's why f dash of x is equal to 0. We have studied that the derivative of a constant function is always 0. Now let's take 2 or 3 examples for that. Let y is equal to 100. Now 100 is the constant function here, which represents y is equal to f of x. So taking dy by dx as per formula, dy dx 100. So its answer is 0. Second example, we are going to take, let y is equal to pi. Now pi is a universal constant again, so dy by dx is equal to d pi by dx, and this answer will be 0. One more example, let y is equal to 2e. Now e is assumed to be another universal constant, so dy by dx is equal to d by dx 2e. So its answer will be 0. Now we have seen that for any constant, its derivative will be 0. Now we take another formula, which is formula number 2, power rule. So y is equal to x raised to power n. Here n is any integer constant. So taking dy by dx on both sides, because we are differentiating with respect to x. Now since n is the power, so we take here and x n minus 1. Then we take the derivative of the function, which is x. So dx over dx. So we can cancel this and it gives us 1. Hence n is equal to n minus 1. So this is the formula which is commonly known as power rule. Now we take example. For example, y is equal to x raised to power 100. dy by dx is equal to d by dx x raised to power 100. It is 100 x raised to power 100 minus 1, and we know that the derivative of x is 1, so we don't write 100 x raised to power 99, and this is the derivative. Actually, I'll solve one or two examples for each formula and then proceed to the next formula, and in detail we will solve the formula questions later. Next formula is constant time function. Constant times function. Now, why we say that constant time function? Time means multiplication, that a constant is being multiplied by the function. So y is equal to k f of x, where k is any constant. So taking dy by dx on both sides, d by dx k f of x. Now this k, which is the constant, will be taken outside, and then we'll apply the formulas. D by x f of x, which is the formula for constant times function. Now example number 1, y is equal to 10 x raised to power 3. Now dy by dx is equal to d by dx 10 x raised to power 3. So dy by dx is equal to 10 is a constant, so as per formula we are going to take it outside. D by dx x cube. Now I'm going this side, applying power rule. 10 3 x raised to power 3 minus 1, and again the derivative of x is 1, so we don't write. 10 3 x raised to power 2 and multiply 10 with 3, because as per formula it is times, which means multiplication. So 10 multiplied by 3 is 30 x square, so we get the derivative dy by dx. Now we are going to discuss two rules side by side, which is sum rule and subtraction rule, only just to see the difference of operation in them. So let y is equal to f of x plus g of x, taking dy by dx on both sides, plus g of x, so we can write d by dx f of x plus d by dx g of x, and then apply all other respective formulas which are applicable in the given function. Now see, in subtraction rule we have only one difference, that is of minus sign. So y is equal to f of x minus g of x dy by dx is equal to d by dx f of x minus g of x. So d by dx f of x minus d by dx g of x. Here we write dy by dx and then apply the corresponding formulas in the respective functions. Now let's take one example for each. We say, for example, y is equal to 2x square plus 5. So dy by dx is equal to d by dx 2x square plus 5. This becomes d by dx 2x square plus d by dx 5. So dy by dx is equal to 2 dx square over dx. Here we have applied the formula constant time function plus the derivative of 5, which is constant, is 0. Therefore 2 into 2x, where we have applied the power rule, so we get 4x dy by dx. Now we take another example for the subtraction rule. We get y is equal to 2x cube minus 5x. So dy by dx is equal to d by dx 2x cube minus 5x d by dx 2x cube minus d by dx 5x. Now first of all, we are going to apply the constant time function. So taking 2 outside, d by dx x cube, again constant time function, 5 dx over dx. So 2, applying power rule, 3x 3 minus 1 minus 5 into 1, because the derivative of x is 1. So 2 3x square minus 5 and finally dy by dx 6x square minus 5. This is the derivative when there is a subtraction rule. Now let's consider an example in which we can use both of these formulas simultaneously. So y is equal to 3x square minus 5x plus 6x cube. dy by dx is equal to d by dx 3x square minus 5x plus 6x cube. d by dx 3x square minus d by dx 5x plus d by dx 6x cube. Now 3 has been taken outside because we are applying the constant time function x square minus 5 dx over dx plus 6 d by dx x cube. Now 3 2x, applying power rule, minus 5, derivative of x is 1 plus 6, again we have applied the power rule, 3x 3 minus 1. So 6x minus 5 plus 6 3x square. So 6x minus 5 plus 18x square. So this is the derivative of the function using sum rule and subtraction rule. Now we are going to start the next formula, which is product rule. This formula is used when there are two different functions being multiplied. For that we have to find out the derivative. So y is equal to f of x into g of x. That's why we say that the two functions are being multiplied. Now f of x is always the first function and g of x is always the second function. Now we write dy by dx is equal to d by dx f of x into g of x. Now the first function will remain as it is. Then we take the derivative of the second function dgx, then put plus, and the second function will remain as it is, and we take the derivative of first function. So this is the product rule and commonly known as u into v formula. So we take an example for that. Y is equal to 2x square plus 3 into 3x square. Now this is our first function, which is f of x, and this is our second function, which is g of x, and we should not change the order of this function. Now put the values of first function and second function in equation A. We will know that where to take the derivative. So dy by dx is equal to 2x square plus 3 d by dx 3x square plus 3x square as it is, and the derivative of first function, that is 2x square plus 3. Now two x square plus 3, and here again we'll first of all apply the constant time function dx plus 3x will remain as it is, and here we are going to apply the sum rule because there are two functions which is being added. D by dx 2x square plus d by dx 3. So here we get 2x square plus 3, and applying the power rule, plus 3x square, and again we are going to apply the constant time function, dx square divided by dx, and we know that 3 is a constant, so its derivative is 0. Now 2x square plus 3 into 6x plus 3x square to 2x square, as we have applied the power rule, and 0 is omitted. Now multiplying 6 inside the terms, so we get 12x cube plus 18x plus 3x square, and this is our 4x multiple. Now finally 2x cube plus 18x plus 12x cube. So on simplification we get 24x cube plus 18x. This is the derivative using product. Now our next formula is division rule. When two functions are divided, how we take the derivative? So let y is equal to f of x whole divided by g of x. Again, f of x is considered first function and it is our second function. This rule also known as division rule, which is u over v formula we commonly use, but here I will use f of x and g of x. So dy by dx is equal to gx whole square, and g of x, which is second function, as it is. Then we take the derivative of first function f of x, put subtraction sign, and the first function will remain as it is, and then we take the derivative of second function. If you understand this formula, then taking the derivative is not so difficult. Now let's start with an example. Y is equal to 3x cube plus x divided by 2x square plus 1. Here 3x cube plus x is f of x and 2x square plus 1 is g of x. Now using the formula g of x, derivative of first function, minus f of x as it is, and derivative of second function divided by square of second function, which is g of x. Now we get 2x square plus 1 whole square and 2x square plus 1 as it is. Now d by dx, because we have to take the derivative of f of x, which is 3x cube plus x minus 3x cube plus x as it is, and the derivative of second function, which is 2x square plus 1. Now 2x square plus 1, applying sum rule, d by dx 3x cube plus dx over dx minus 3x cube plus x, and again applying the sum rule, d by dx 2x square plus d by dx 1 and divided by 2x square plus 1 whole square. Now 2x square plus 1, applying constant time function, d by dx x cube, and the derivative of x is 1 as we know, minus 3x cube plus x, again applying constant time function, to dx square over dx, and 0 because the derivative of 1 is 0, it is a constant. Now 2x square plus 1 whole square. Now 2x square plus 1 3. Now applying the power rule, 3 minus 1 plus 1 minus 3x cube plus x to 2x 2 minus 1 whole divided by 2x square plus 1 whole square. Now 2x square plus 1 3x square plus 1 minus 3x cube plus x to 2x whole divided by 2x square plus 1 whole square. Now we are just going to simplify it. 2x square plus 1, this is 9x square plus 1 minus 3x cube plus x and 4x over 2x square plus 1 whole square. Now just simplifying it, this is 18 x raised to power 4 plus 2x square plus 9x square plus 1 minus 12x raised to power 4 plus 4x square and whole divided by 2x square plus 1 whole square. This is 18x4 plus 2x square plus 9x square plus 1 minus 12x4 minus 4x square and whole divided by 2x square plus 1 whole square. Now we are going to simplify it. We get 6x4 plus 7x square plus 1 whole divided by 2x square plus 1 whole square. This is our answer. So far we have studied the different formulas by which we are going to find out the derivatives. Now we shall start some questions regarding the formulas. Now question number 1. Y is equal to 4x raised to power 7. Now in this question we are going to use two formulas, that is constant time function and the second one is the power rule. So taking derivative, d by dx, 4 is constant, so we take 4 outside, d by dx 7, as we have used y is equal to k f of x, dy by dx is equal to k d by dx f of x, which is constant time function formula. Now here we are going to use power rule. So 4, 7 x raised to power 6 and multiplying 4 with 7. This is our derivative. Now question number 2. Y is equal to 1 over 2 x raised to power 4 plus 7. Again we are going to use first the constant time function formula. So dy by dx is equal to d by dx 1 over 2 x raised to power 4 plus 7. So 1 over 2 taken outside, dx x raised to power 4 plus 7 and 1 over 2 dx power 4 over dx plus d7 by dx 1 over 2 4x 4 minus 1 plus 0, because the derivative of constant is 0. So 1 over 2 4x raised to power 3 multiplying 1 by 2 and this will be cancelled as 2, so 2x power 3. Therefore dy by dx is equal to 2x power 3. Now question number 3. F of x is equal to x raised to power minus 3 plus 1 over x raised to power 7. Now this 1 over x raised to power 7 will be changed to the numerator as x raised to power minus 7, and then we are going to apply the power rule. So f dash of x is d by dx x raised to power minus 3 plus x raised to power minus 7. So d by dx x raised to power minus 3 plus d by dx x raised to power minus 7. So applying power rule, x raised to power minus 3 minus 1 plus minus 7 x raised to power minus 7 minus 1. Here minus 3 x raised to power minus 4 minus 7 x raised to power minus 8. And finally minus 3 over x raised to power 4 minus 7 divided by x raised to power 8 is the derivative. Now question number 4. Here we are going to use power rule, and this is your function f of x. So the formula that we will use will be y is equal to f raised to power n. When we take the derivative, dy by dx is equal to n f of x raised to power n minus 1 and derivative of function which is f of x. This is actually the power rule for the function. So here we take f dash of x is equal to 2 3x square plus 1 2 minus 1, then the derivative of the function as stated in the formula 3x square plus 1. So 2 3x square plus 1, and applying the sum rule plus 1. Now 2 3x square plus 1 3 dx square by dx plus 0 2 3x square plus 1 3 2x 2 3x square plus 1 and 6x, and finally 12x 3x square plus 1. This is your f dash of x. Now on simplification we can further simplify as f dash of x is equal to 36x cube plus 12x. Now question number 5, we see that it is a combination of sum rule and subtraction rule. So taking dy by dx 5x square minus 3x plus 1 d by dx 5x square minus d by dx 3x plus d by dx 1. So 5 dx square over dx minus 3 dx over dx and 0. Now 5 2x minus 3 10x minus 3. This is our dy by dx. Now question number 6, find dx by dt. Here the function x will be differentiated with respect to the variable t. So dx by dt is equal to d by dt t square minus 1. So dt square over dt minus d by dt 1, and applying power rule we get t minus 0 is equal to 2t dx by dt. Now question number 7, find dy by dx at x is equal to 2. This means that after finding the derivative of the given function, we will replace x where there is x by the given value, which is 2. So dy by dx is equal to d by dx 2x square plus 5x. Now we take the derivative, d by dx 2x square plus d by dx 5x. Now 2 dx square plus 5 dx over dx. 2x plus 5 4x plus 5 dy by dx. Now at dy by dx, this means x is equal to 2, we are going to put is 4x plus 5 4 2 plus 5 8 plus 5, that is 30. So this means that whenever we obtain the derivative and at the end we have to replace each x with the given constant. Now question number 9, here we have to find dy by dx. We see that there are two functions being multiplied, which is f of x and this is g of x, and are being multiplied. So we are going to use product rule here. So the product rule is dy by dx is equal to first function as it is, then the derivative of second function plus second function as it is and derivative of first function divided by dx. Now we will replace the values in f of x, g of x, and f of x is replaced here. So 2 minus x minus 3x square d by dx 7 plus x5 plus 7 plus x raised to power 5 d by dx 2 minus x minus 3x cube. Now in this way it will be very easy to remember that which function is to be derivative. Now 2 minus x minus 3x square. Now here we are going to apply the sum rule, d 7 by x plus d x raised to power 5 dx plus 7 x raised to power 5 and d by dx minus dx over dx minus d by dx 3x cube. Now 2x 3x square 7 is constant, so its derivative will be 0. And now we are going to apply a power rule, which is x raised to power 5 minus 1 plus 7 plus x raised to power 5. 2 is constant, derivative is 0, minus x derivative is 1 minus 3 dx cube over dx. 2 minus x minus 3x square, 5x raised to power 4 plus 7x raised to power 5 minus 1 minus 3, 3x raised to power 3 minus 1, which is the power rule. Now simplifying, that is 10x raised to power 4 minus 5x raised to power 5 minus 15x raised to power 6, which means that we have multiplied 5 with this term, and this term. So 7 plus x raised to power 5 minus 3 minus 9x raised to power 2. 10x raised to power 4 minus 5x raised to power 5 minus 15x raised to power 6 plus minus 21 minus 63x square minus 3x raised to power 5 minus 9x raised to power 7. So 10x raised to power 4 minus 5x raised to power 5 minus 15x raised to power 6 minus 21 minus 63x square minus 3x raised to power 5 minus 9x raised to power 7, and this is the derivative of the given function. Now we can rearrange in ascending order, which means starting from the highest power of the variable to the lowest one, that is a constant. So minus 9 x raised to power 7 minus 15 x raised to power 6 minus 5 x raised to power 5 minus 3 x raised to power 5, then plus 10 x raised to power 4 minus 63 x raised to power 2 and minus 21. Now these two terms can be simplified further. So 9x raised to power 7 minus 15x raised to power 6 minus 8x raised to power 5 plus 10x raised to power 4 minus 63x raised to power 2 minus 21 is our derivative. Now question number 10. It is again two functions are multiplied, hence we are going to use product rule. So dy by dx is equal to f of x d by dx g of x plus g of x as it is, and derivative of first function, which is f of x. Now putting the values, 1 over x plus 1 over x square d by dx 3x cube plus 27 plus 3x cube plus 27 d by dx 1 over x plus 1 over x square. Now 1 over x plus 1 over x square, applying sum rule, d by dx 3x cube plus d by dx 27 plus 3x cube plus 27 d by dx. And one thing we can make here, that is the fraction that is 1 over x can be written as x raised to power minus 1, so that when we apply the power rule it will be very easy to solve, plus d by dx x raised to power minus 2. 1 over x plus 1 over x square 3 dx cube dx plus 0 because 27 is constant and its derivative is 0, plus 3x cube plus 27 and minus 1 x raised to power minus 1. We have applied the power rule here. Again we are going to apply the power rule, x raised to power minus 2 minus 1. Now 1 over x plus 1 over x square 3x square, applying power rule, plus 3x cube plus 27 and minus x raised to power minus 2 because we normally don't use minus 1, minus 2 x raised to power minus 3. Now 1 over x plus 1 over x square 9x square plus 3x cube plus 27 and minus 1 over x square minus 2 over x cube. Now we are going to simplifying it. 9x square over x plus 9x square over x square plus 3x cube minus 1 over x square minus 3x cube 2 over x cube minus 27 over x square and minus 27 into 2 over x cube. Now we can cancel this term, this term, and this term, and this term is cancelled. So 9x plus 9 minus, similarly x square and x cube is also cancelled, so we get 3x and minus 6. This x cube and this x cube is cancelled, minus 27 over x square and minus 54 over x cube. Now simplifying further, this is 9x minus 3x is 6x plus 3 minus 27 over x square minus 54 over x cube is the derivative for the given function. Now question number 11, which is again product of two functions, so we are going to use product rule, dy by dx, and this time I am not going to write the formula, rather just simply putting the values in the formula for the differentials. X square plus x d by dx x square minus x plus x square minus x and d by dx x square plus x. So x square plus x, applying here the subtraction rule, minus dx over dx plus x square minus x, again applying sum rule, dx square over dx plus dx over dx, x square plus x, applying power rule we get 2x minus 1 plus x square minus x, again applying power rule, so 2x and plus 1 which is the derivative of x. Now just simplifying, 2x cube minus x square plus 2x square minus x plus 2x cube plus x square minus 2x square minus x. Now we will see there may be some terms which are cancelled, and then simplifying these terms. Here if we see, this is x square and this x square is cancelled, plus 2x square and minus 2x square is cancelled, and the remaining terms are added. 2x cube plus 2x cube minus x which are the remaining terms, so 4x cube minus 2x is the derivative. Now in this question number 12, y is equal to 3x plus 4 divided by x square plus 1, the two functions are being divided, f of x and this is g of x. So we are going to use division rule. And what is the division rule? dy by dx is equal to square of second function, as it is, then we take the derivative of first function minus sign and f of x d by dx and second function differential. These formulas actually we have already studied before starting these questions, but still for your convenience I will write the formula. Dy by dx. Now the second function is x square plus 1. Now we take the derivative of first function, that is 3x plus 4 minus 3x plus 4 as it is, and we take the derivative of first function x square plus 1 and whole divided by the second function square plus 1. Now we will take the derivative of the required functions x square plus 1 d by dx 3x plus d4 by dx minus 3x plus 4 and dx square by dx plus d of 1 which is a constant and whole divided by x square plus 1 whole square. Now x square plus 1 3 because dx over dx, and this is 0, minus minus 3x plus 4, again applying power rule, 2x plus 0 whole divided by x square plus 1 whole square. So here dy by dx, x square plus 1, 3 minus 3x plus 4, 2x. This we have obtained after simplification. Three x square plus 3 minus 6x square minus 8x, x square plus 1 whole square, and this is minus 3x square plus 3 minus 8x over x square plus 1 whole square, and this is our derivative. Now question number 13, y is equal to under root x into 2 plus 1, then x minus 1 divided by x plus 3. Now this question is a combination of two formulas. First one is the division formula, and then second one is the product rule. The product rule will be applied on first function, that is f of x, and this is the g of x. So applying the division rule, dy by dx is equal to x plus 3 derivative of first function 2 under root x plus 1 and x minus 1. Here we will apply the product rule. 2 under root x plus 1, x minus 1, and d by dx, x plus 3. Now if you understand this question, it will be very easy to solve all the complex nature derivative questions. X plus 3. Now applying here product rule, 2 under root x plus 1 d by dx, x minus 1 plus x minus 1 d by dx, 2 under root x plus 1 minus 2 under root x plus 1 into x minus 1 and dx over dx plus d by dx 3 and whole divided by x plus 3 whole square. So x plus 3, 2 under root x plus 1 dx over dx minus d of 1 divided by d of x plus x minus 1 d by dx, 2 under root x plus d by dx 1 minus 2 under root x plus 1, x minus 1, 1 plus 0. And whole divided by x plus 3 whole square. X plus 3, 2 under root x plus 1, 1 minus 0, plus x minus 1, 2, 1 by 2, x raised to power minus 1 by 2, plus 0, minus 2 under root x plus 1, x minus 1, x plus 3 whole square. Now x plus 3, 2 under root x plus 1, plus x minus 1, and here this 2 and this 2 is cancelled and we get 1 over under root x minus 2 under root x plus 1 into x minus 1 and whole divided by x plus 3 whole square. Now on simplification, 2x raised to power 3 by 2 plus x plus 6 under root x plus 3 plus x over under root x minus 1 over under root x minus 2 x raised to power 3 by 2 minus 2 under root x plus x minus 1 whole divided by x plus 3 whole square. Now 2x 3 by 2 plus x plus 6 under root x plus 3 plus x into x raised to power minus 1 by 2 minus 1 by under root x minus 2x 3 by 2 plus 2 under root x minus x plus 1 whole divided by x plus 3 whole square. And now we see that some terms will be cancelled to this minus x, and this x is cancelled, and now we are going to simplify it. It is 6 under root x plus 3 plus x raised to power 1 by 2 minus 1 over under root x plus 2 under root x and plus 1 whole divided by x plus 3 whole square. Now few terms are added. This will be 6 under root x raised to power 1 by 2, and this become under root x plus 4 minus 1 over under root x whole divided by x plus 3 whole square, and further taking the LCM of the under root of the numerator, we can say x whole divided by x plus 3 whole square, 9x plus 4 under root x minus 1 becomes 9x plus 4 under root x minus 1 whole divided by under root x and x plus 3 whole square, which is our answer. Now in question number 14, again we have two different functions. This is your f of x and this is your g of x, and now we'll use product rule, and when we differentiate g of x we will use division rule, but we will use simultaneously both of these functions, not by differentiating g of x first and then differentiating f of x. So dy by dx is equal to first function as it is, derivative of second function plus g of x as it is, and d by dx derivative of first function. Now putting the values of f of x and g of x, 2 under root x plus 1 derivative of g of x, which is 2 minus x divided by x square plus 3 of x plus g of x as it is, 2 minus x over x square plus 3 of x, and d by dx is 2 under root x plus 1. Now we are going to differentiate 2 under root x plus 1. Now here we are going to use division rule, which means that we are taking the derivative of g of x, which is 2 minus x divided by x square plus 3 of x. Now x square plus 3 of x whole square and x square plus 3 of x as it is, then the derivative of first function, that is 2 minus x minus 2 minus x, and derivative of second function, which is x square plus 3 of x plus 2 minus x over x square plus 3 of x, and applying here sum rule, d by dx 2 under root x plus d by dx 1. Now 2 under root x plus 1 x square plus 3 of x, and the derivative of this is d2 by dx minus dx over dx minus 2 minus x and dx square over dx plus d by dx 3x plus 2 minus x over x square plus 3x 2x raised to power minus 1 by 2 divided by 2 plus 0, and this function has, up to this part we have applied the division rule, so square of the second function, 2 under root x plus 1 x square plus 3x, this is 0 minus 1 minus 2 minus x 2x plus 3 whole divided by x square plus 3 of x whole square plus 2 minus x over x square plus 3x and 1 over under root x, because this 2 and this 2 is cancelled. 2 under root x plus 1 x square plus 3x minus 1 minus 2 minus x 2x plus 3 whole divided by x square plus 3x whole square plus 2 minus x over x square plus 3x 1 over under root x. Now after multiplying and simplifying, we get 2 under root x plus 1 x square minus 4x minus 6 over x square plus 3x whole square plus 2 minus x over x square plus 3x and this under root. Now taking x square plus 3x common, 2 under root x plus 1 over x square plus 3x x square minus 4x minus 6 over x square plus 3x plus 2 minus x over under root x. Now after taking LCM, we get 2 under root x plus 1 over x square plus 3x x square plus 3x under root x x square minus 4x minus 6 under root x plus 2 minus x x square plus 3x. Now after simplifying, we get the final term for the derivative, that is 2 under root x plus 1 whole divided by x square plus 3x 5 by 2 minus 4x 3 by 2 minus 6x 1 by 2 plus 6x minus x square whole divided by x square plus 3x into under root x, and this is the derivative for the given function. Further simplification is not required. This is the answer. In this question number 15, y is equal to x raised to power 7 plus 2x minus 3 whole power 3. We will use the power rule for the function. So dy by dx, and the formula was f of x whole power n. Its differential will be n f of x n minus 1, then the derivative of the given function. Now in this question, f of x is this term and 3 is the n. So dy by dx is equal to 3 x raised to power 7 plus 2x minus 3 minus 1, then the derivative x raised to power 7 plus 2x minus 3 dx. So 3 x raised to power 7 plus 2x minus 3 square, and now taking the derivative dx raised to power 7. Here we have applied the sum rule as well as the subtraction rule. D by dx 2x minus d by dx 3 x raised to power 7 plus 2x minus 3 whole square 7 x raised to power 6 applied power rule plus 2 minus 0. So 3 x raised to power 7 plus 2x minus 3 whole square and 7 x raised to power 6 plus 2 is the derivative for the given function. So this is our answer. Now in this question number 16, we have to find dy by dx for the function lambda into lambda naught plus lambda raised to power 6 divided by 2 minus lambda naught, where lambda naught is a constant. Now since it is given that lambda naught is a constant, so entire term in the denominator, this term is now constant. So we will use the formula y is equal to k f of x, which is the constant time function, and for this dy by dx is equal to k d by dx, and then we will apply the corresponding formulas. So take dy by d lambda is equal to d by d lambda lambda naught plus lambda 6 whole divided by 2 minus lambda naught. Now since 2 minus lambda naught is constant, so we will take out, and it is d by d lambda lambda naught plus lambda raised to power 6 1 over 2 minus lambda naught, applying sum rule d by d lambda naught whole divided by d lambda plus d lambda raised to power 6 divided by d lambda. 1 over 2 minus lambda naught. Since lambda naught is constant, so again we will take lambda naught out. So d lambda by d lambda plus 6 lambda 6 minus 1. Now 1 over 2 minus lambda naught into 1 because we are differentiating lambda with respect to lambda plus 6 lambda raised to power 5 and finally lambda naught plus 6 raised to power 5 and whole divided by 2 minus lambda naught is the derivative for d by d lambda. This is our answer. Now question number 17, find d square y by dx square, which means we have to find out the second derivative for the given function y is equal to 7x cube minus 5x square plus x. Now how to find out the second derivative? We will first of all find the first derivative and then we will find the second derivative. So first of all, dy by dx is equal to d by dx 7x cube minus 5x square plus x. Again applying sum and subtraction rule here. D by dx 7x cube minus x square by dx plus dx over dx. Now 7 3x raised to power 2 by applying the power rule minus 5 2x and plus 1. So this is 21x square minus 10x plus 1 and this is our first derivative. Now for second derivative, we take the derivative of the already obtained function, that is taking d by dx dy by dx is equal to d by dx x square minus 10x plus 1. So now this becomes d2y by dx square is equal to d by dx 21 x square minus d by dx 10x plus d by dx 1. Now this is 21 d by dx x square minus 10 dx over dx plus 0. So 21 2x, we have applied the power rule here, minus 10 and the derivative of x is 1. Now multiplying 21 with 2 is 42x minus 10 and this is your second derivative which we have to find out. Now in this question number 18, again we have to find out the second derivative for the given function y is equal to x plus 1 divided by x. But here we will use division rule. So dy by dx x plus 1 over x. Now applying division rule, x square x d by dx x plus 1 minus x plus 1 d by dx x. So we obtain x. Again applying sum rule, dx over dx plus d1 over dx minus x plus 1 and 1, which is the derivative of x. Now x square, so x 1 plus 0 minus x plus 1 and whole divided by x square. Now we can start from here. X minus 1 over x square. This x and this x is cancelled, so we get minus 1 over x square, and this is the first derivative. Dy by dx is equal to minus 1 over x square. Now for the second derivative, take dy by dx again on both sides. Dy by dx is equal to d by dx minus x raised to power minus 2. As previous, I have taken the denominator to the numerator with a change in the negative sign of the power. So d2y by dx square is equal to minus 2 x raised to power minus 2 minus 1, and it is 2 because minus into minus is plus, and x raised to power minus 3, and this is our second derivative which was required in the question. So d square y by dx square is equal to 2 whole divided by x raised to power 3. This is our second derivative answer. This was our last question. So hopefully, dear students, you have followed, and if you feel any difficulty in any question, you can ask me.